Welcome back, everybody. I'm joined by Professor Nick Braithwaite. So, Nick, can you tell me a little bit about your work, and are you enjoying Moon Night?
Well, first of all, I'm enjoying Moon Night, yes, and my work is to do with the two aspects to it: ionized gases, plasmas, the sorts of things that are around the Earth in the ionosphere, and also the things that the Sun is made of, but we make them here on the Earth in the lab and study them there. Actually used for manufacturing semiconductor circuits like we have in the technology that you're watching me with now. But I'm also interested in remote experiments and operating instruments at a distance. We do this for our students routinely at a distance of, well, it might be a few thousand miles. I'm really fascinated by the idea of operating instruments on, say, the surface of the Moon or on the surface of Mars, which is taking this idea of remote experimentation even further.
Okay, cool. So how are you making these plasmas and gases in your lab, and then the technology you mentioned? Are you implementing any of it in a space mission currently, or is that maybe a future plan? Hopefully.
No, it's a very nice link. We make them using electrical energy, so we break down the gas using electricity. Are we using them right now? We are looking at the idea of making thrusters. Plasma thrusters are being used right now. They're used for satellite control, maybe for pushing some into orbit, maybe for pushing others out of orbit. And there you ionize a gas and you electrically accelerate the particles, and that gives you thrusters. You throw the particles out of the back. It's just like a rocket engine, but it's an electrical rocket rather than a chemical rocket.
So that's cleaner energy, is that right?
Yes, I guess it's cleaner energy. You're drawing energy from the sun, I suppose, to charge your batteries in order to do it, rather than carrying the chemicals up there. So it's not only clean while it's happening, but it's also more effective to put it up there without the burn of the fuels in the atmosphere.
And that's because it's lighter, so it costs less money to launch the same amount. Is that right?
Well, it's because you're not having to carry the fuel that you then throw out. Well, you do have to carry something, of course, to throw out of the back. You've got to take a gas and ionize that gas, but you don't have to take liquid rocket propellant or solid rocket propellant and use that. It's just another way of doing it. I mean, the nice thing about science and engineering is there's usually another way, and that's part of the fascination of it. Sometimes it's fashion, sometimes it's availability of technologies and so on.
Yeah, there's always a weird and interesting way of doing things. So you mentioned linking it to space missions and you wanting to look at how to do your remote learning work that you've done here at the Open University, and maybe taking that to doing remote experiments on the Moon. Is there anything in particular you'd want to do on the Moon as an experiment remotely?
Gosh, that's a really challenging one. Almost anything that is an instrument there sending information back that you can interact with. People have the idea of going there because they want to make the decisions about what we do next. Hands-on, they call it. But actually, you don't need to be there to be hands-on. You need to have a connection, a control line, and then you can still make those real-time or slightly delayed time decisions. So I think it's a really exciting prospect.
So do you think then that, given the technology and how we're improving on that at the moment, that we will be on the Moon, boots on the ground again soon, living on the Moon maybe in the next 10 years?
Well, this is the part about the remote experiments. I possibly think you don't need to put the boots on the ground. It's high risk, high emotion stuff, and if you could do it remotely, it would be an interesting variation. But I should say all of this comes together in our module on space science. We have a master's course on space science and engineering.
And you can find information on that on the Open University website, is that correct?
You certainly can, and in that we've got the ability to give people the experience of lunar missions by a blend of doing things here on Earth and at a distance, and giving that feel, training people in that kind of environment ready for space work.
That's fantastic. So have you learned anything new from Moon Night today then?
I'll tell you what I've seen today, which is humbling. I've seen pieces of the Moon. In a block of perspex. I've read about it before, I've seen microscope images before, but I've not seen the real stuff. So I've seen the real stuff tonight.
Yeah, that's really fascinating. Thank you very much, Professor Nick Braithwaite. So again, if you have any questions, please use the hashtags that are conveniently behind me, or tweet at ThomasJ_Barrett or at OUSPS, etc., etc. We're probably going to have maybe one or so more interviews before the live stream cuts to our special guest for the evening on, well, you'll have to wait and see. See you later.